Question number 20. This is a circle theorem question. Read what they tell you very carefully. P, Q, R and S are points on a circle, okay? P, X, R and Q, X, S are straight lines, okay? And PX is equal to SX. That's why they're marked with those little dashes. You've also got two angles, 50 degrees and 27 degrees, which they haven't mentioned in the words of the question there. Okay, and what do I have to do? I have to prove that QS is not a diameter of the circle. How am I going to do that? Well, let's have a look at it. What I'm going to do is I realise I've got an isosceles triangle there. XPS is isosceles because XP and XS are equal. They tell us that. And so I can work out the angles down at P and at S. I do 180 minus 50 and then I halve it. So I get that those two angles are both 65 degrees. And don't forget to give all the reasoning for that. Those are the base angles of an isosceles triangle. Okay, what do I do now? We'll take away the isosceles triangle for the moment. And look, there's a butterfly shape. And I know that the angles in the opposite tips of the wings of the butterfly are equal. In other words, that angle over there, QPX, is 27 degrees, the same as the 27 degrees XSR, which they told us about. Now, that's all fine, just don't use the words butterfly shape. The correct words to use are angles in the same segment. Okay. What I can do now is this. I can add up the angles at P, the 27 degrees and the 65 degrees. They add up to 92 degrees. Now then, if QS were a diameter of the circle, then QPS would be a semicircle. And you know that the angle in a semicircle is a right angle. In other words, the angle up at P must be 90 degrees. Well, it isn't. It's 92 degrees, and therefore QS can't be quite a diameter. It's probably not very far away, because 92 degrees is close to 90 degrees, but it's not a diameter. So we write all that down. If QS were a diameter, then QPS would be 90 degrees, and that's because of the angle in a semicircle being a right angle, and therefore QS is not a diameter.